Welcome everyone. In this video, we are going to start learning the basics of coordinate geometry. So please watch the video till the end because here I have covered each and every concept very nicely and in a very easy way. I am making this video for you all. So please like the video, comment, subscribe and share. Thank you very much for supporting me also. So let's begin. First, you can see in this figure that we have four quadrants. Okay, we have four quadrants. Four quadrant means one quarter, second quarter, third quarter, fourth quarter. That is, any graph will be divided into four quadrants, right? And these x dash, xox dash and yoy dash together are called as coordinate axis. That is, what is coordinate axis? Coordinate axis are the two perpendicular lines which intersect at a point 0. What is a Cartesian plane? Cartesian plane, as the name suggests, it is a plane. How do we obtain that Cartesian plane? When we draw these coordinate axes on the Cartesian plane perpendicular to each other. That is, these are 90 degrees to each other, right? Then we obtain Cartesian plane. And this Cartesian plane can also be called as coordinate plane or xy plane because the axes involved are x-axis and y-axis. Now what is x-axis? X-axis is the horizontal line, and here in this figure it is denoted by xox dash. What is y-axis? Y-axis is the vertical line, and in this figure it is denoted by yoy dash. Now what is origin? Origin O is the point of intersection of the x-axis and y-axis. So where the x-axis and y-axis meet, that point is called as origin O, and it is written as 0, 0 because here we know origin O, it is meeting at 0. So x is also 0 and y is also 0. Now let us see some more very interesting basic concepts of coordinate geometry. Abscissa. What is abscissa? Abscissa is the distance of any point from the y-axis. It is also called as x-coordinate. Example, if you see in this, the points are 3, minus 2. That is, x-coordinate is 3 and y-coordinate is minus 2. There is a distance of the point when you draw any graph, in that the distance measured from the y-axis is called as x-coordinate. So here 3 is the abscissa. Okay, that is the distance measured from the y-axis. Now what is ordinate? Ordinate is the distance of any point from x-axis, and that is also called as y-coordinate. Don't get confused between ordinate and coordinate. Both x and y are called as coordinates, but only y-coordinate is called as ordinate. See in this point 5, 4, here we know the y-coordinate is here. This is my x-coordinate, 4, that is y-coordinate. So here I can say that the distance 4 will be drawn from the x-axis. Where is x-axis? We saw right in this figure just now. From the x-axis, how much distance we get, that is nothing but our y-coordinate or ordinate. Now what do we mean by coordinate? The x-coordinate or abscissa or y-coordinate or ordinate are called coordinates of the point, as I've explained to you. That is, here we can say 5 and 4 both are said to be coordinates. Now what is a point on x-axis? Always remember, if you want to plot a point on x-axis, the point is lying on the x-axis. It is not lying in the middle of the graph. It is lying exactly on the x-axis. When the point lies exactly on the x-axis, remember x-coordinate is x only, but as it is lying on the x-axis, that is, it is not lying on y-axis, means y-coordinate is 0. So the point on x-axis is x, 0. Similarly, what is the point on y-axis? The point on y-axis is 0, y. As it is lying on y-axis means it will have y magnitude, but as it is not lying on x-axis, it will have 0 magnitude of x-axis. So always remember, the point on x-axis is x, 0 and the point on y-axis is 0, y. Now let us come to the very interesting topic, distance formula, which is the first method of coordinate geometry of class 10th. So these formulas are common for both CBSE and SSE. Okay. So here if you observe, this is my Cartesian plane or xy plane, and in this I am considering there is a line which is lying in the Cartesian plane, and that line is having 2 points. One point is A and second point is B, and if I extend this A to the x-axis, it is meeting at x1, and if I extend this A to the y-axis, it is meeting in y1. Similarly, if I extend this B at x-axis, it is meeting at x2. If I extend this b at y-axis, it is meeting at y2. So I can say b is x2, y2 and a is x1, y1. So I have the coordinates of a and b. Now I want to calculate the distance between this a point and b point. What is the distance between this a point and b point? It is very easy to remember. Always remember the distance between AB is the square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is my x2, x2 minus x1 whole square plus y2 minus y1 whole square. Now what is the distance of a point P, x, y from the origin O0, 0? Now let us consider that a line is there which is connected to origin O and a point P, x, y. Here also I want to calculate the distance between the point P and the origin O. The distance is OP is equals to, we know what is the general formula, root of x2 minus x1 whole square plus y2 minus y1 whole square. So here I don't have x2 and x1. I directly have x1, x and y in place of x2 and y2. So x minus 0 whole square plus y minus 0 whole square. X minus 0 is x only. And so x minus 0 whole square means x square and y minus 0 means y only. So y minus 0 whole square means y square only. So always remember the distance of a point P, x, y, if we have to measure from the origin 0, 0, it will be simply root of x square plus y square. Let us come to the next formula, section formula. Now with the name section, we can understand that there must be some ratio involved in this formula. So remember, the point that divides a line joining A, x1, y1 and B, x2, y2 internally in the ratio m1 is to m2 is P of x, y is equals to. Now in this, remember, same concept is involved. That is, in order to calculate the coordinates of point A, I have to extend on the x-axis, I have to extend on the y-axis, I'll get x1, y1. Similarly here, extend on the x-axis, extend on the y-axis, I'll get x2 and y2 as coordinates of B. And let us suppose there is a point which is lying on this line P, and let us suppose this point P is dividing this line segment in the ratio m1 is to m2. For example, this is my smaller part and this second part is my bigger part from PB. So I want to calculate how much distance or how much ratio this, how much magnitude this point P is dividing this line segment in the Cartesian plane. So that formula in which this point is dividing the line segment in how much ratio, that is given by P of x, y is equals to, we have m1 x2, m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. In some textbooks, instead of m1 and m2, they take it as m and n also. There is a ratio, there is m is to n. So there the formula will be mx2 plus nx1 by m plus n, comma my2 plus my1 by m plus n. Okay, but here the formula will be this. Okay, it's very easy to remember. 1, 2, remember like this, 2, 1, and here m1, m2. Here 1, 2, 1, 2. Here we have x coordinates x2 and x1. Here we have y coordinates y2 and y1. And in all this we have plus. Remember, whenever the point divides the line joining the points internally, always we will have plus sign. Suppose in the question if it asks us externally, then we will have minus sign. But in your syllabus, only internally, dividing the line segment internally is given in the syllabus. And this part, that is internally, is given mostly in CBSE textbooks. In SSC, internally word is not mentioned. Okay, anyways, if internally is mentioned or not, take this formula. That is m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. Next formula is midpoint formula. This is also very interesting and my most favorite formula. Here we need to find out what is my middle point of the line segment AB. So the middle point or the geometrical center of the line AB is given by x1 plus x2 by 2, as we have 2 points and as it is a midpoint, that is by 2, comma y1 plus y2 divided by 2. Very easy to learn, right? Next is centroid formula. What is centroid? Centroid is the point where all the 3 lines of the 3 vertices, when they extend, the 3 lines, that is you can see here, BG, AG and CG, they meet at the center of the triangle. That is called as centroid and that is indicated by G. Suppose this vertex of this triangle is A, x1, y1, second vertex is B, x2, y2, and third vertex is C, x3, y3. Similarly, if I extend this A, I'm getting x1, x2, x3, y1, y2, and this y3, let us suppose this is outside. Since this is a 2D figure, I will not get y3 in this. 2D means I'm drawing this on paper, right? So I cannot show you y3. But remember, y3 is also a distance which is from C to this y-axis, right? So how to calculate centroid? As we have three vertices here, and as the center is for these three vertices, okay, that is the line. The point obtained by joining these three lines is called as centroid. That is why here we have divided by 3. Just now we saw in midpoint formula it is divided by 2, x1 plus x2 by 2, y1 plus y2 by 2 is for midpoint formula of a line, whereas for centroid of triangle ABC we have g is equals to x1 plus x2 plus x3 by 3, as it is a triangle and 3 vertices are there, y1 plus y2 plus y3 by 3. Very easy. Here you have x coordinates and here you have y coordinates. Okay, it's very easy to score marks now. Next is area of triangle. In area of triangle we have two formulas. One is general formula. Okay, if in the exam it does not mention any method, you can use general formula. This is obtained by, you know, what is the general formula of area of triangle? The general formula of area of triangle is half into base into height. So again we are assuming that there is a triangle which is placed in my Cartesian plane of x, y. This is my A vertex, B vertex and C vertex. And when I extend this, it is meeting at some point Q, and that will be x2. This point is P, that is will be x1, and this point is C, that will be R, that is nothing but x3. Similarly, here I have y1, y2, y3. So I'm getting the point x1, y1, x2, y2, x3, y3. Now, remember, since I have three vertices, x1, y1, x2, y2, x3, y3, there is three coordinates. Here, same formula will be there, half into base into height. So, half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. It's very easy to remember. At the beginning of the brackets, I have x1, x2 and x3. And remember like this, y2 minus y3, y3 minus y1, y1 minus y2. Remember like this, 1, 2, 3, 2, 3, 1, 3, 1, 2. It is a cyclic order. It is a general formula of area of triangle. What is the area of triangle by Heron's formula? Heron's formula is by the name of the mathematician Heron. He has derived a formula for calculating the area of triangle when we have the length of the sides are given. Here the length of the sides are not given. Here the coordinates x1, y1, x2, y2 and x3, y3 of the points are given. Suppose if the length of the sides are given to me in a triangle. Suppose a triangle is having a side A and the triangle is and the side of the triangle is B and the third side of the triangle is C. First calculate the semi-perimeter according to Heron's formula. The semi-perimeter is indicated with a symbol small s. Small s is equals to A plus B plus C by 2. The semi-perimeter is given by adding all the three sides divided by 2. There is nothing but it is a perimeter divided by 2. The semi-perimeter means half, right? That is why A plus B plus C by 2. Then calculate the area. How to calculate the area? Area is equals to square root of S. What is S? Just now we calculate A plus B plus C by 2 into S minus A. The length what you will get. Into S minus B into S minus C. There is also a very easy formula. Now remember, the area of triangle will always be 0 if the points are collinear. What do we mean by collinear points? Collinear points are the points that all lie in the same line, whether they are close together, far apart or form a line segment or a line. Remember, all the 3 points are lying on the line. They are not forming a triangle. When the points form a triangle, then we can say the triangle will have some area. As here, the points are lying on a single line. They are not lying in the triangle. That is why the area of triangle will be 0 when the lines are collinear. Remember that. Okay, col means together, linear means line.
So if in the question it asks us to prove if the points are collinear or not, simply find out the area of the triangle, and when you prove area of triangle is 0, you can say the points are collinear. Now the next concept is, what is the equation of a straight line passing through the point A x1 y1 and B x2 y2? For example, there is a straight line having points A x1 y1 and B x2 y2. Then we can calculate the slope of the line, and that slope of the line is given by m. Always remember, slope of the line can be calculated by subtracting the y coordinate of second point minus y coordinate of first point divided by x coordinate of second point minus x coordinate of first point. That is, m is equals to y2 minus y1 by x2 minus x1. This m is called as slope of the line. And in the question, if it asks us to find out slope in terms of theta, that is degrees, and angle, then we can use the formula slope m is equals to tan theta. When we solve these sums, you can understand what I'm talking about, but this is very important concept in SSC. Now, there are some more tips which come in your exams, like you'll be tested based on the knowledge of shapes, okay? Here, the distance formula will be used. You have to find out the distance of AB, you have to find out the distance of AD, you have to find out the distance of CD, BC, then diagonal BD, diagonal AC, and suppose if it asks you, show that the points A, x1, y1, B, x2, y2, C, x3, y3, D, x4, y4 are the points of a rhombus. How to know whether the points are of a rhombus? You have to prove all the four sides are equal. That is, after finding AB, BC, CD and DA distance, if all four are equal and if the diagonals, that is BD and AC, are not equal, that is BD distance and ED distance, AC distance is not equal, we can say the points are the points of a rhombus. That is, the coordinates are the coordinates of a rhombus. Coordinates means this four vertices of the rhombus. Similarly, if the coordinates are of a square, then in square, remember, all these sides are also equal and the diagonals of a square are also equal. That is, suppose this is my B point and this is my C point here. So BC is equals to AD. That is why here I am writing small d and small d for diagonals. That is, diagonals are also equal and the sides are also equal in a square. So when I have AB is equals to BC is equals to CD is equals to D, that is, all four sides are equal, and AC is equals to BD, that is, diagonals are equal, I can say the points, the coordinates are of a square. And more condition is that the diagonals, they bisect each other perpendicularly in case of rhombus, and in the case of square also the diagonals bisect each other perpendicularly, and this, we know that all the sides of a square are perpendicular to each other, but in case of rhombus the sides are not perpendicular to each other. That is the main difference between the rhombus and a square. These are parallel to each other, the sides AB and CD, but they are not at 90 degrees, whereas in case of square they are perpendicular, that is 90 degrees. And here the diagonals are equal, here the diagonals are not equal in case of rhombus. Now let us come whether to know in the question, if it asks us the point coordinates are of the parallelogram. How do you know? Parallelogram means it is same like rectangle, but the difference in parallelogram and rectangle is that here the diagonals AC and BD are not equal and opposite sides will be equal in case of parallelogram, and also opposite sides will be parallel in case of parallelogram. Here, that is why here I have double arrows, because these both sides are parallel and also equal, whereas here AB and CD I have single arrows because these opposite sides are parallel and also equal. Whereas the diagonals, as you can see here, single line and here double lines are not equal. So parallelogram means they are not at perpendicular and opposite sides are equal, and rectangle also opposite sides are equal and opposite sides are parallel, but here the sides are at 90 degrees to each other, and here the diagonals are also equal. So if you want to prove that the coordinates are of rectangle, remember opposite sides are also equal and diagonals are also equal in case of rectangle. So this is same for rectangle and square. Remember, diagonals are equal in rectangle and square, whereas in parallelogram diagonals are not equal. Next is, if suppose coordinates are forming a right triangle, we have to prove. Then we know that whenever we have a right angle triangle, we have used this concept in many sums, even in small classes we have seen that the right triangle means you have to follow Pythagoras theorem. That is, what is Pythagoras theorem? Suppose the longest side of a triangle is known as hypotenuse. This is called as base, and this B is called as height of the triangle. That is, these two are my general sides and this is my hypotenuse. So remember, in a right angle triangle, the Pythagoras theorem states that hypotenuse square is equals to opposite side square plus adjacent side square. That is, hypotenuse square is equals to side square plus side square. So if suppose my hypotenuse is C, my height is B, and my adjacent side is A, I can say hypotenuse square, that is C square, is equals to adjacent square, that is A square, plus height square, that is B square. And I know that this point P should be at 90 degrees with respect to this side QP. So if you want to prove that it is a right triangle, means it should satisfy this condition: C square is equals to A square plus B square. That's it, guys, for this video. Hope you have understood all the basic formula of coordinate geometry. If you have any doubt or if you want any recommendation, you can please comment below. Thank you very much for watching. Please do subscribe my channel, because I'm going to make more interesting and more easy videos for you all. So please keep the notification bell on after subscribing. Thank you very much.